In this question, we have a biker who is riding with a velocity of 25 kilometers an hour when a dog suddenly runs out 10 meters in front of them. The biker immediately slams their brakes and comes to a stop right in front of the dog. We are asked, what was the biker's deceleration as they were stopping? In case you don't know what deceleration is, it's just asking us, what was the rate at which the biker slowed down? To start solving this question, let's write what was given. Well, we know the bike rider's initial velocity, VI. It was 25 kilometers an hour. Normally, when you're solving kinematic problems, you want to convert everything to your SI units, which in this case would be meters per second. So we'll convert the initial velocity from kilometers per hour to meters per second. So how do we do this conversion? Well, you always want to think, how can I get the units I need? We have kilometers. How can we convert that to meters? Well, we know we can use the conversion factor, which says 1,000 meters is 1 kilometer. And now we cancel out our kilometers and we're left with just meters. Next, we have to get rid of the hours and replace it with seconds. Well, we know 1 hour is 60 minutes. We can use that conversion factor to get rid of hours. Now we have to get rid of minutes. Well, we know 1 minute is 60 seconds. And with that, we cancel out the minutes. Now we can see the only units that are left are meters and seconds. When we do the math, we find that the initial velocity is 6.9 meters per second. Next, we can identify the bike rider's final velocity. We know the rider is coming to a stop. When an object is stopped, it's not moving, so its velocity is 0. In this case, we'll write that the final velocity is 0 meters per second. Finally, we were given the change in position, delta x, which was 10 meters. We always want to ask ourselves, what are we solving for? And we were asked, what is the biker's deceleration? Which means we're solving for the acceleration variable a. Now let's take a look at our kinematic equations to choose which one we should use. The way you can choose what kinematic equation to use is by looking at what variables are you missing. We are missing delta t, the time it takes for the biker to come to a stop. When you look at our kinematic equations, you can see that 3 out of the 4 kinematic equations include delta t, so we can't use those. We need to use this kinematic equation because it is missing delta t. This kinematic equation says that Vf squared is equal to Vi squared plus 2a delta x. And now that we have our kinematic equation, we can solve for acceleration. We will start by rearranging our equation so that we can isolate for a, the acceleration. Once we've isolated for the acceleration, we can plug our values into the equation. So we know that Vf squared is equal to 0 meters per second. And we know that Vi squared is equal to 6.9 meters per second. Finally, we know our change in position delta x is 10 meters. Once we do the math, we find that our acceleration is equal to negative 2.4 meters per second squared. Now, what you always want to do when you answer a question is look at the answer and ask yourself, does this answer make sense? Our value is negative. We got a negative acceleration. What does this mean? Well, our object was slowing down. And when an object is slowing down, the velocity vector and acceleration vector are pointed in opposite directions. So in this case, the biker's velocity vector was pointed to the right. That means the acceleration vector has to be pointed to the left. And vectors that are directed to the left are designated with a negative sign. Now, what if our object was speeding up? Well, if an object is speeding up, the velocity vector and acceleration vector are pointed in the same direction. So for this example, the velocity vector is pointed to the right, which means the acceleration vector has to be pointed to the right. And vectors that are directed to the right are designated with a positive value. So our answer does make sense because our object was slowing down, so our acceleration is negative.